aligned, which you see that's actually a little loose there, because that's a nut, and that piece that got threaded in it's a little loose there. So if you hit the edge, like, you'll shatter these things. So we don't want to break this thing. It's an artifact of factory farm history. No, we probably want to, like, we would take out that, we probably have to, like, cut this off, put a new tube here, and then rework that. There's like a big threaded, like 1.5 inch thread in there. Looks like it just wore out and stuff. So we'd have to redesign this to make it work. Or we can do, so on this one, what I would do instead is, this is ready to punch holes here. Like, this thing moves down, so this has got the full pressure on this. So we'd mount that punch element onto this. That'll be the next step. Let's maybe take that one out of commission, decommission that one.
Okay, so this is a hydraulic metal punch, and we're going to use this to do what exactly?
This is a hydraulic metal shear. You can cut shear up to like 14 inches of 1 inch steel, or you can do like 1/2 by 6 angle.
Okay.
1 inch steel and a punch.
Yeah, we don't have the punch element here. But, yeah, this thing is well done. So this thing, you can cut 1 inch steel on it, like butter.
Whoa.
Pretty cool. It's a hardened steel blade. It's regular tool steel blade. So, yeah.
How much did it take you to, how much time?
6 months
6 months.
with one person.
One
Okay.
person, 6 months. Wow.
Was insane. This is a lot of complexity here. So we designed it.
Can we get like a 5-minute intro to the metalworking machines we're about to use and what we're going to use them for? So it's crystal clear. I think we're doing this right now.
Yeah.
Okay. All right, so this is number one. This is
We're not using that in the morning. We'll use it later.
okay.
So that's afternoon. That's a shear. We gotta connect hydraulic hoses to a power unit. Like, we'll drive the micro track in here then, and we'll use the micro track power takeoff. There's a valve back there that we run in order to run it. We gotta clean this stuff out here. Beyond that, there's mag drills, which we got some experience and no gloves on that. Next tools are torches.
Can I see the map?
I can show you later.
Yeah.
It's easy. I mean, it's obvious.
People are already informed about it, so they can help you. So this is a torch. Whoever's going to be on that team will do that. But I mean, the brief intro is this is oxygen and acetylene. This is what we put on the torch table. Like, once we do that, so that's coming up in a couple of weeks. But you just put this head on a CNC axis, and you've got automated cutting, which we've done before for tractor parts and things. And then we could never get our act together to build the next one that actually wasn't used. We built a bunch of other prototypes, but by now we've got, we'll just nail it out. There's another wrench, if you want to do that. Our wrenches are scattered all over the place. So this is oxygen, big tank. This is acetylene. Now, what's the future of this? Just FYI,
Hydrogen.
oxyhydrogen cutting.
Yeah.
It's better, faster, stronger, and it's cooler.
Brown's gas.
You can also, there's a really,
It's like, and you ask, why does everybody not use it? It's industrial inertia with the oil industry,
there's a company
in
called,
my opinion. Because actually, fuel cutting started with hydrogen. Because people could get oxygen and hydrogen from water pretty easily. So if you go back to the 1850s or something like that, there was no acetylene. They started with hydrogen. So we know it works, and it's a much cleaner cut.
They were using electrolysis to produce oxygen.
Yep.
Cool.
And the cool thing about it is you can cut anything with it, like stainless and aluminum, whereas like stainless and aluminum you can't really cut with an oxyacetylene torch.
Melt bricks with it.
Uh-huh. Run your car with it.
Yeah.
Uh-huh.
there's a company called Magna Gas, I think, and they have some sort of system where they excite the gas with an electrical impulse and lets them cut through anything. And the gas they use is just made from food waste and like any type of waste.
This is plasma, is that what it is?
Yeah, like a plasma torch somehow.
Love the plasma.
Yeah.
I have a little suggestion. Maybe we'll all get to it after lunch, but I would love to do a little bit of everything. So if we have 3 teams set up, a group of 3 doing that. Wait. 3 guys doing that, 3 guys, 4 guys doing that. If one guy changes, then the rest of the group can inform, like, this is the way you do it, and we can all quickly
Yeah.
run through it.
It's not a full rotation, just Damn, I like that.
Very good.
Yeah.
So one goes first, and
So
then all
much
the
for
group
theory, and I hope
comes,
we
and the
can
guy that was first
nail down the
teaches the
practical
other.
implementation as well.
Yeah, or like 2 guys stay, 1 guy go, and then it gets a new one, and like, okay, hold this, keep your fingers out of that, and you know.
Okay.
And then Martin has time to show each group so they
Yeah.
know collectively how to do it.
Yep.
Not to jump the gun too, but cutting width and waist. If we're taking the big 10-footers and we need to cut them down and get 2-dimension sections, do we like start at the ends and make sure the waist is in the middle because of the cut one?
Oh, yeah, if you do that, that's a good idea there.
Okay.
Exactly, that's forward thinking there. Yeah, do the 2 clean cuts if you,
Sweet.
because you have, then we can, for the sleeve that goes for the wheel, that can be dirty. That's, I mean, the edges are not critical on that. So, the cutoffs, the 1-foot cutoff, we need, oh yeah, so if we got on our list, 4 1-foot cutoffs for the mounting of the wheel.
I'm guessing each one of these machines is gonna have a different cut width.
It
Probably.
is, this is, kerf is as accurate as your hand, this is steady. down to like 1/16, maybe, 1/16 of an inch. Okay. That's, I mean, this may be like, more like a little bigger than, there's different nozzle sizes. Here we use a pretty big one, there's like, there's super tiny ones that you can have curved like a plasma cutter. Unless there's like tiny, very tiny nozzles, up to like a millimeter or 2, kind of like 3D printing.
The 12-inch for the wheels can be rough, can be torched.
Yep, yep, it can be torched. So there's grinders, the other tool, which are, those are, just real quick,
Cut the
do we wanna
straight line.
go through that right now, just basic
So
thing?
you cut a straight line with that, like by hand.
Grinders, yep.
Put your